Good afternoon, everybody. Welcome to Chem 1211 with your host, me, Dr. White. And today I will go through quiz number 4 review. Don't forget, I will be giving this Thursday quiz 4 online. And I'd like to remind you at the end of the month, the 29th, 30th, and the 31st of July, I will be giving test 2 and the final exam at the Glen Ellen COD Testing Center. You have to take it at that testing center. You can't take it at any other, and you can't take it at any other time. Remember, the Glen Ellen Testing Center is open only from 9 a.m. to 5 p.m. on those days. If you need the time to take tests, you got to get there well before they close. So make sure you set up the time block. I'd highly recommend you take my test number 2, take a break, come back that same time, same day after a break, and take the final exam. If you don't take test 2 and the final exam over those 3 days, you'll get a 0. All right, let's go to quiz review number 4. Now, this quiz review number 4, is secretly hidden in the lecture section of Blackboard under the title file name Chem 1211 quiz number 4 review. All right, this deals with solutions. And you should know a solution contains a solvent, only one solvent, and that's the component of the solution present in the greatest amount. Next, you should know that a solute or solutes are all the other components in a solution. And right now, the air I'm breathing, I'm breathing, is a solution of mainly oxygen and nitrogen. And nitrogen is present in the greatest amount. So nitrogen is the solvent in air, and oxygen is the solute in air. Now, next, I talked about a colloidal dispersion. And at first thought, you'd think, oh, that's a solution. It's not. How do you tell the difference? Oh, it's time to show off one of my favorite flashlights made by the greatest flashlight maker in the world right now, Hank Wang. And, oops, too bright. You can tell a solution because light passes through it. Now, if this were a colloidal dispersion, no light passes through it. That's because they're little particles floating inside of another material, not solvent, and those little particles block the light. So if this were a colloidal dispersion, it would not let light go through it. But since it's not a dispersion, you can see the red light going through it. Oops, sorry about that. Again, this is my favorite flashlight. And this is a Noctagon K9 III. In case you haven't known, you can look up there some more of mine. Dr. White is a flashaholic. I love flashlights. If you ever want to have some fun, go to the subreddit r/flashlight and another subreddit just for Hank Wang's flashlight, r/sub Hank flashlight or something like that. I forgot what it is. All right, let's continue on. Now, an important concept in solutions is the concept of like dissolved like. Now, like solutes are soluble in like solvents, and we break this down to polar solutes are soluble in polar solvents, and nonpolar solutes are soluble in nonpolar solvents. And when you mix the two together, guess what? They don't form a solution. They separate into a heterogeneous mixture. Now, water, alcohols, and salts like sodium chloride, table salt, are polar. Vegetable oil, gasoline, Vaseline, baby oil, and even grease and dirt are nonpolar. When you take my 12-12, where I also teach organic at Elgin Community College, Chem 170, you'll find out, like dissolve like, is how soap works to get grease and dirt off your hands, your clothes, anything else. And you should know this. Now, there's certain terms you should know. And one is the solubility of a solute. And that's, the maximum amount of solute that will dissolve in a given amount of solvent. So when you've reached that maximum amount, you can't put one more in there, one more molecule, or 1/100th of a thousandth of a gram, because otherwise it will precipitate out. The solid falls to the bottom, won't dissolve. Now, there's some terms I would like you to know. One is saturated solution. And a saturated solution contains the maximum amount of solute that can be dissolved under the conditions at which the solution exists. Now, a dilute solution means there's just a small amount of solute relative to the amount that could dissolve. A concentrated solution, like concentrated orange juice, a solution that contains a large amount of solute relative to the amount that could dissolve. And finally, one of the most important, aqueous solution. An aqueous solution tells you that the solvent of that solution is water. And it's abbreviated by bracket AQ close bracket. Now, when we make the solutions, it's important to know how much of a solute is present in the solvent. That way you can make consistent solutions again. And there are different ways of determining that, such as by percent weight, percent volume. But the one I'd like you to know for this class is molarity. And if I write something in red, it's important. It even says on here, very important. Know this. And the molarity, which is abbreviated by bracket capital M close bracket of the solution, is the ratio giving the number of moles of solute per liter of solution. So molarity equals moles of solute per 1 liter of solution. Now, 1 liter equals 1,000 milliliters, so molarity also equals moles of solute per 1,000 milliliters. And a common practice in the lab is the two-step molarity problem. This is where you're trying to go from milliliters to grams. And I'm going to go through one of these in a little while. But there's step one, you go from milliliters to moles. Step two, you go from moles to grams. Now, just to remind you, 1 mole of an element equals atomic weight of that element in grams. 1 mole of a compound equals the molecular weight of that compound in grams. And the molecular weight of that compound equals the sum of all atomic weights. Now, I hope you all went through chapter 12 and 13, solution practice problems. And unfortunately, I just realized some of these I have in cursive I thought I changed everything to type so you could read it, but I'll go through it just in case you can't read it. Give an example of a colloidal dispersion that you use in your daily life. And there's latex paint, milk, and your blood. Now, give an example of a solution that you use in your daily life. Tea, pop. Don't forget, Dr. White is from the Chicagoland area. And that carbonated beverage that you buy in bottles and cans that's non-alcoholic, which people on the East Coast call soda, we call pop, like the good stuff, Dr. Pepper or Werner's. If you don't know what Werner's is, you're missing a lot. It's a very highly carbonated, very spicy, very good ginger ale. Now, if you made sugar and water, mix it together, that would be a solution. As I mentioned earlier, air is a solution. And the next couple of problems you can do on your own, but the top one is always the solvent, the bottom one, nope, I take it back. This is solvent, this is solute. All right, now you should know, what does 1.34 capital M HCl mean? Well, as soon as you see a number, capital M, and a chemical formula, that means molarity. And molarity is moles of solute. That's the chemical after the capital M per 1,000 milliliters. You could put around 1 liter too, but for this class, we use 1,000 milliliters. So this is what it means. Now, let's look at number 7. What does 4.56 times 10 to the third capital M NaCl bracket AQ close bracket mean? And what is the solvent of the solution? Well, first of all, see the capital M, molarity. So it's 4.56 times 10 to the third moles of NaCl per 1,000 milliliters. What's the solvent? Bracket, AQ, close bracket, tells you the solvent is water. All right, let's do number 8, because this will show you how to use molarity. How many moles of sodium chloride are in 125 milliliters of a 3.45 capital M NaCl solution, sodium chloride? Table salt. Now, what are we trying to find? Moles of sodium chloride. What are we given? This volume and this number, 3.45 capital M NaCl. I wonder what that means. Well, capital M means molarity. Moles of solute per 1,000 milliliters. Well, in this case, 3.45 capital M NaCl means 3.45 moles of NaCl per 1,000 milliliters. Now, the only number we really have to use is 125 milliliters. We want to get to moles of sodium chloride. So it's time to use your good buddy. I haven't used this in a while. Your good friend, unit analysis. Now I feel better. All right. So using your good buddy, your good friend, unit analysis, whatever we're trying to get to goes on top of the ratio, moles of NaCl. Whatever we're trying to get rid of goes underneath, milliliters. Where do we get those numbers? Right here from the molarity, what it means. 3.45 moles of NaCl per 1,000 milliliters. Do the math. Now, remember, 125 is three significant figures. 3.45 is three significant figures. However, the 1,000 is part of the definition, and that's an exact number. So if we look at this, three significant figures, exact number, our answer has three significant figures. And don't forget, I take off points if you don't get it right. Now, let's look at number 11. How many G, which is grams, of NaCl are needed to make 345 milliliters of a 6.789 capital M NaCl solution? And this is an everyday occurrence where you make stock solutions or certain molarity from a solid or liquid or whatever, pure substance. So we're trying to find grams of NaCl. We're given milliliters and we're given the molarity. There's no way in one step I can convert milliliters to grams. So what do? Well, we look at important information. Let me open it up. I don't have it open. And if we look at important information, quiz number 4, you'll see molarity two-step. Step 1, we convert milliliters to moles. Step 2, we convert moles to grams, which I hope you all learned by test number 1 and also quiz number 3. So we need 2 steps. Step 1, we go milliliters to moles. And for those who can't read cursive, so I have 345 moles. I want to get milliliters. I want to get the moles of NaCl. I use my good buddy, my good friend, to figure out what goes on top and bottom of this ratio to convert milliliters to moles. And by using your good buddy, your good friend, unit analysis, whatever goes on top, whatever you're trying to get to, goes on top of the ratio, moles of NaCl. Whatever I'm trying to get rid of goes underneath, milliliters. And where do we get that ratio? Well, if you look over here, we have 6.789 capital M NaCl. The capital M tells us molarity. And if we look at important information, quiz 3, molarity equals moles of solute per 1,000 milliliters of solution. So this capital M means there's 6.789 moles of NaCl per 1,000 milliliters. And that's where I get these numbers. Now, this is 3 significant. 4, the 1,000 is an exact number. I get 2.34 moles. Am I done? No, I'm trying to get 2 grams of NaCl. So I now need to do my second step. Moles of whatever we just calculated in step 1 to grams. In this case, 2.34 moles of NaCl. We want to go to grams of NaCl, sodium chloride. Whatever we're trying to get to goes on top of the ratio. Whatever we're trying to get rid of goes underneath. And where do we find a relationship between moles of a compound and grams of a compound? Well, in case you forgot, important information, quiz 4. 1 mole of a compound equals the molecular weight of that compound in grams, and the molecular weight is the sum of all atomic weights in that compound. Well, for sodium chloride, 1 sodium, the 3 significant figures, 23.0. 1 chlorine, the 3 significant figures, remember the number under the symbol is the atomic weight, and you should use that, the 3 significant figures is 35.5. And therefore, when I add them up, I get 58.5. Remember, you get the same number of significant figures to the right of the decimal. I like those special effects, to the right of the decimal, as the number with the few significant figures to the right of the decimal. Stop that. And this has 1, this has 1, and you don't have to do anything because your answer has 1 already. So put the 58.5 up here, the 1 here, 3 significant, 3, 1 is exact number, 3 significant figures. Now notice I have both ways. And this is a multi-step calculation. I'm a round off at each step person, but a lot of people round off at the end. Well, I calculate both ways because I'm not going to force you to round off the way I do in a multi-step calculation. But it's still the best way. At least I think so. And that's the same answer. And with that, I'm done with the review for quiz number 4. Make sure you study, do the practice problems. Also, make sure you keep up with the labs. Hand them in. This Wednesday, I'm going to be spending all day catching up. In the summer, I fall behind. It's a pretty hectic schedule, just like it is for you, it is for me. With 2 classes, I have about 40, 80 labs a week I have to grade. So it's easy to fall behind. Well, with that, I'm done for today. And don't forget, this Thursday and Friday, I'll be giving quiz 4 online. And later this week, I have a special surprise for you. Yep. Hopefully you're watching this video later this week. I'll have a special surprise. With that, I'm going to say, gang gesund, and bye now. I stole that from Granny and the Beverly Hillbillies. Bye.